Hi everyone! Today we're going to clear up one of the most common points of confusion in physics, the difference between average speed and average velocity. Many people use these two words interchangeably, but in a physics test mixing them up will cost you points. Let's consider a simple example. This is your house. You have to meet up with your friends at the park, which is 500 meters away from where you live. However, before going to the park, you want to go and buy some snacks to share with your friends. So you grab your bike, ride all the way to the grocery store, buy the snacks, then turn around and eventually reach your friends. The total time it takes you is 8 minutes and 20 seconds. If I ask you for the average speed and average velocity, would you give me the same number? Let's find out. Average speed is the total distance traveled divided by the total time taken. To calculate the average speed, we need to determine first the total distance traveled. Your movement is made up of two parts. In the first part, the distance traveled is 1500 meters. The second distance traveled can be found by difference, and that equals 1000 meters. So overall the total distance is 2500 meters. The total time taken is known, it is 8 minutes 20 seconds, but to calculate speed we need to transform this into seconds. That is very easy to do because 1 minute equals 20 seconds. So to calculate the total time you have to do 8 times 60 plus 20, and if you do the maths that equals 500 seconds. So the average speed is 2500 meters divided by 500 seconds, and the result is 5 meters per second. We have found that the speed unit is meters per second, which is the unit used in the international system, indicated with SI. Other common units are kilometers per hour and miles per hour. In general, in any scientific work, the unit of speed is expressed as the ratio between a unit of distance divided by a unit of time. It is known, for instance, that India moves north at an average speed of 5 cm per year. This is a very low velocity, so it wouldn't make sense to use meters per second or kilometers per hour. This process, though, has been going on for the last 50 million years, and has caused a couple of side effects like, the Himalayas. Consider that if India moves south instead of north, the average speed would always be the same, although the world geography will look very different. We can say then that distance and speed is scalar, in the sense that no information is given about the direction. The speedometer in your car, in fact, does not know which way you're traveling. Direction is needed instead to calculate average velocity, because that is displacement divided by total time taken. To define displacement, we have to consider the motion and its direction. So in our example, you move 1500 meters to the right first, and then 1000 meters to the left. Ultimately, it is as if you had moved only 500 meters to the right, and that is your displacement. Displacement, in fact, is the change in position from the start to the end of the motion with its direction. So in this example we can say that the displacement is 500 meters to the right, or if you use a compass, you can say that displacement is 500 meters east. But in a linear motion, probably the best way to express displacement is to consider negative and positive sign. What do we mean by that? This is your neighborhood again. The park is 500 meters away from where you live. Your school is also 500 meters away, but in the opposite direction compared to the park. So its position will be defined as negative 500 meters. So if you go from your house to the park, your displacement is positive 500 meters, whereas if you go from your house to the school, displacement is negative 500 meters. As you can see, displacement is a vector, meaning that it is a quantity which has magnitude and direction. Graphically, vectors are represented as arrows, as you can see in this picture. In our example, we can then say that displacement is positive 500 meters. We saw earlier that the total time taken is 500 seconds. So average velocity is positive 500 meters divided by 500 seconds, and as a result it is positive 1 meters per second. We can see then that also average velocity is a vector. In this table I have summarized the main differences between average speed and average velocity. Average speed just uses total path, is a scalar quantity, so no information is given about direction, is always a positive number. While average velocity uses the change in position, which is the displacement, and is a vector because it has a direction. So it can be positive, negative, or even zero. How is it possible to have zero average velocity? Let's go back to our problem. Imagine that after seeing your friends you tell them goodbye and ride home. What happens to the distance and to the displacement? The distance has increased by another 500 meters, so it goes up to 3000 meters. But what about the displacement? Remember that displacement is the change in position between the start and end point. But you started and ended your trip in the same position, which is your house, so the displacement is 0. Therefore, the average velocity is also 0. Whenever you have a motion that starts and ends in the same point, average velocity is in fact 0. Now that you have the theory down, you need to practice. I've put together a dedicated video with some exam problems on linear motion right here. Go check it out and see if you can solve them. And if this video helped you understand speed and velocity, make sure to hit the subscribe button. See you in the next lesson.